Right. The first question. What is the speed of computer measured in nanoseconds, kiloseconds, gigahertz, megabytes?
Gigahertz.
Hertz, yes. Maybe gigahertz, megahertz, any hertz, right? What is incorrect? Regarding the GPU and CPU, GPU were originally designed to accelerate the rendering of 3D graphics. Is that correct?
Correct.
Yes, correct. CPU and GPUs have not any common features.
Incorrect.
Yes, not any common features. CPU and GPU are having most of the common features are there, but some are different, right? Most are similar, but some are different. So this is the incorrect one. Let's see the third one. Alternately referred to as a processor, central processor, or microprocessor, microcontroller. That means what are the other names that we can refer for the CPU? Right, that is correct. ALU and CU are parts of CPU. That also correct. The speed of CPU called as clock speed. Is that correct? Yes, correct. The CPU speed we called as clock speed, right? So here the incorrect one is the second one. It's having most of the features commonly, right? The only difference is the GPU is just the main objective of that one is to processing of the graphics and images. Just it accelerate the graphic side. The CPU is also just doing some processing, right? But not that is not good for image processing. But both are doing some kind of data processing, right? What is the correct one? What is don't take this answer. Just using a mistake, I just click on that. Cache memory is a volatile memory. Is this correct?
Yes, teacher.
What is mean by volatile? Yeah, what is mean by volatile? Anybody? Yes. What is mean by volatile? Yes. Although the power, the electricity is there or not, the volatile. Volatile means what? Until the power is available, only the data will be stored in the memory. Once the power is not there, the data will be erased. So is that cache memory is a volatile one?
Yes, teacher.
Yes. RAM is an example for a secondary storage device.
Incorrect.
Incorrect. RAM is the primary storage device. RAM is the primary storage. Secondary storages are non-volatile.
Yes, true.
Yes, true. Register memory is the smallest and fastest memory in a computer.
True.
True.
Correct.
Cache memory is faster than the system RAM.
Correct.
Yes, that also correct. So what is the incorrect one?
RAM is an example for secondary storage.
Secondary
The
storage
second one.
device.
What is incorrect regarding RAM? Data is copied from secondary storage to RAM as and when it is needed. The data are copying from secondary to RAM loop. Is that correct?
Yes, teacher.
Yes, from the secondary storages, in order to access by the CPU, definitely those data should be copied into the RAM. Otherwise, the CPU can't directly access the data that is in the secondary storage devices. RAM is a computer secondary memory.
That's incorrect.
Incorrect. That is the primary memory. RAM is a volatile memory.
Yes, teacher.
Yes. Files on a computer are temporarily stored in RAM whilst being used by the CPU.
Yes, teacher.
Yes. The files are stored in temporary. That is correct. And also that is used by the CPU. DRAM is used for main memory of the computer.
Yes, teacher.
Yes, that is correct. What is the usage of SRAM? The DRAM is used as the main memory. What is the purpose of SRAM? That is normally used as the cache memory, right? Cache memory is SRAM. Main memory ganne DRAM, right? So what is the incorrect one then? Yeah, the second one. Which of the following is exclusively a sequential access storage device? Sequential access means what? The data access according to an order. That means it's starting from the first cell onwards, it's going on. So, here's my pen. Right. Hard disk, floppy disk, magnetic tape, and DVD. What is the well-known sequential accessing device here? That is
Magnetic tape.
magnetic tape.
Magnetic tape.
Yes, yes, magnetic tape. Next, which of the following memory cannot be directly accessed by the CPU and on a maybe directly accessed karana bari memory එක? What is the memory that cannot be directly accessed? Actually, the complete question should be accessed by the CPU. Anyway, right? Primary memory is can it directly accessed by the CPU?
Yes, teacher.
Yes. Secondary memory?
No, teacher.
No. RAM?
Yes, teacher.
Yes. DRAM?
Yes, teacher.
Yes, because the primary memory, RAM and DRAM, all the three are referring to the same thing. Ne? So here the different one is the secondary memory. All of these three are referring to the main memory. So which of the following is a non-volatile memory chip? Non-volatile means permanently can store the data. That means no effect of the power, the electricity, the data are permanently storing. EEPROM, electronic erasable programmable read-only memory. Is that the non-volatile one?
Yes, teacher.
Yes. RAM?
No, teacher.
No, that is a volatile. DRAM?
Also volatile.
Volatile. SRAM?
Also volatile.
Yeah, all the RAMs are volatile. So the non-volatile is the ROM. Maybe any ROM, right? EEPROM or PROM or EEPROM or whatever ROM. Which device contains a cathode ray tube?
Monitor.
Monitor. What are the name that we refer to that kind of monitors? Normally, what is it called as? CRT. CRT monitors. Yes. Which of the following memory is very fast memory in a computer?
Cache memory.
Cache memory.
Cache memory. Yes. If the register memory is there, the answer should be that one.
Register.
Okay? Yeah. Out of these four, the cache memory we can take. The register memory are faster than this one as well. The cache memory works between where it's reside normally.
CPU and RAM.
CPU and RAM. Yeah, it's very close to the CPU rather than RAM. Right? The RAM is some far away to the CPU, but the close one is the cache memory. Which of the following devices used for both input and output? What about that one?
Modem.
Modem. Yes, yes, modem. Right, modem. That means when we are discussing the networking lesson, we will detail discuss that one. It just do the modulation as well as the demodulation. Right, so it's just take the analog signal and just convert into digital as well as the vice versa. Right. Which of the following statement is correct about the DVD? DVD is an optical disc. Is that correct?
Yes, teacher.
Yes. DVD, CD, Blu-ray, all are optical discs. DVD is very costly.
False.
Wrong. That is not cost. It is not a portable device. Like it cannot be carried anywhere easily.
False, teacher.
False. It has very poor video and sound quality.
That's also false.
Yeah, we can't tell like that. So the answer is DVD is very costly. That is the sorry. DVD.
It's an optical disc, teacher.
Yeah, optical disc. Correct one, Nehan. Correct one. The symbol used in an assembly languages are normally called as what? Mnemonics. Mnemonics. It's spell like just don't spell M, mnemonics. Select examples for big data. Social media data, is that a big data? So you can just select more than one answer here. Just some check boxes are there. Social media data, is that correct? That means Facebook, Instagram. Yeah, it's collecting big data. Data handling in a bank. What about that? Is that a kind of big data? No, big data means just not the data that is collecting in a bank. More than that, right? Data held in New York Stock Exchange.
Big data.
Yes, correct. Data generated by a jet engine.
Also big data.
Yes. Data handled daily in Google Cloud. Yes, right. So all we can take except the second one. What is incorrect regarding big data? Big data is a collection of data that is huge in volume, yet growing exponentially with time. Is that correct?
Yes, teacher.
Yes. It is a data with so large size and complexity that none of traditional data management tools can store it or process it efficiently.
Correct, teacher.
Yes, correct. Big data is also a data but with huge size.
Yes, correct.
Yeah. To make sense of this large amount of data, it is not a challenge of this era.
False.
False. It is a challenge actually, right? How this kind of big data are handled. That is from within a second, billions of data is gathered from the social media and elsewhere, right? So it's a challenge for this era. The volume of data that one has to deal has been exploded to unimaginable levels with the time.
Correct, teacher.
Yes. So what is the incorrect one?
Fourth one, teacher.
Fourth one. To make sense of large amount. Yes. Which scenario does not an example for the applicability of information? Is that information can take to make decisions?
Yes, teacher.
Yes. To make predictions?
Yes, teacher.
Yes. To make policies?
Yes, teacher.
Yes. To make plans and schedules?
Yes, teacher.
Yes, teacher.
Yes. To make data?
No, teacher.
No, teacher.
No. From data we make information, but not the other way around. This what is not a drawback of manual data processing, consuming more time cost. Drawback, right?
It's a drawback, teacher.
Yeah, it's a
Drawback.
drawback. Possibility for errors,
Also a drawback.
drawback. Data inconsistency,
Drawback, teacher.
yes, drawback. Data inconsistency means same data, it's appearing in same places in different forms. Now say it's just a name, name it's just take like Gunatilaka, right? Gunatilaka. Normally the some of them it's just writing as the last letter as A, or some are just using E as the last name, last character, right? So when there are the same name is appearing in two places in two different ways. One is having A and one is having E. That means there is an inconsistency, right? So maybe the manual data processing have those kind of things. Need not technology.
That is not a drawback.
Yeah, that is correct, but it's not a drawback. That is a kind of advantage of this manual. No need of technology. Technology, the people who can't deal with the technology, that is good for them. Data duplication,
Drawback.
that is a drawback. So not a drawback. So the fourth one. What is not an application of new IT era? Cloud computing, is that a new application?
Yes.
Yes. Mobile computing?
Yes,
Yes,
teacher.
teacher.
Yes. www?
Yes, teacher.
Yes. Mobile communication?
Yes, teacher.
Yes. Word processing?
No,
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 teacher.
that is not a new trend. What is incorrect about internet? Foundation is the ARPANET. ARPANET. Is that correct?
Yes, teacher.
Yes. It's a network of networks.
Yes, teacher.
Yes. Today the internet is public, cooperative, and self-sustaining facility. Yes, that
Yes,
is
teacher.
correct. That means from public domains there are, right? That means there are people in public domain, and cooperative manner also there, and that means the individual person is also there, right? So all the three domains people are there. Internet uses a set of protocols called HTTP or HTTPS. Is that correct?
No, teacher.
No. Yeah. What is the protocol that it used by the internet?
TCP or TCP?
TCP/IP. TCP/IP is the protocol it's used, right? The HTTP is used where?
HTML document exchange.
Yeah, that means in www, it uses HTTP or HTTPS, right? www is an application of internet. Is that correct? It's just a service. Yes, www is only one application of internet. There are many like email, chat, video conferencing, file transferring. There are many facilities under the internet. So www is only just one facility, and there it uses HTTP or HTTPS, right? Internet uses TCP/IP. Select services of internet: IP telephone, IP TV, www, email, internet relay chat. You have to consider all the answers here. All the answers given here, you have to just decide all those are services or not. Can we
Services.
take all? Yeah, we can take all. Video conferencing, www, FTP.
Yes, teacher.
Yes. Telnet, www, FTP, IPV, IPTV. Video conferencing, email, chat, FTP. Telnet. Telnet is just a remote accessing. It's another service now. Because of this telnet here, we can take select services of internet. Select services of internet. Kyotin prashne වැරදි. Select the answer that is not including the services of internet. Not are the services of an internet. Not all, but only one we can take here. The telnet we can't take as a service of internet. Is that so? Telnet, the remote login service. IP telephone is correct, right? That means through the internet we are taking telephone calls. IPTV means through the internet we are watching television. www means just exchanging web pages. Email, you know. Here the chat. IR chat means just chat. Video conferencing, correct. Again, this one correct. FTP, file transferring protocol. Yeah, that is also we are doing through the internet. What about the telnet? Telnet. Let's see the answer later. May prashne වැරදි, right? Select services of internet. So you can select more than one here. Just some check boxes now. We can take this one. Video conferencing. Let's keep this one. Right, something wrong with that question. What is incorrect regarding www? Tim Berners-Lee is the developer. Is that correct?
Yes, teacher.
Yes, teacher.
Yes. Direct by the W3 consortium. Yes, correct. That is controlled by W3C. HTTP is the set of rules for exchanging files there.
Yes, teacher.
Yes. The documents contains hypertexts.
Yes, teacher.
Yes. Hypertext are similar to the hyperlinks of www.
No,
False,
teacher.
teacher.
No, those are two different concepts. Hypertext documents are just a link with the hyperlinks. What is incorrect? Mobile communication involves the transmission of information over a distance without the help of wires, cables, or any other forms of electrical conductors. Is that correct regarding mobile communication?
Yes, teacher.
Yes. A cloud is present at a remote location and provides services over a network. Is that correct?
Yes, teacher.
Yes, teacher.
Yes. IaaS, PaaS, and SaaS are the services of mobile computing.
No, teacher. They are
No, teacher.
services of cloud
No,
computing.
those are the services of what?
Cloud computing.
Cloud computing services. Applications such as email, web conferencing, customer relationship management run in clouds. Some applications of clouds. That is correct, right? To accommodate multiple users in mobile computing, PDMA, FDMA are used, the technologies. That is correct. Frequency division, time division, multiplexes. These two technologies that we mentioned in the slide as well, right? That is needed to have this mobile computing. Some technologies. Multiple access. When we are sharing the same communication channel in order to share by different devices, we have to have this kind of technologies. What is incorrect regarding systems? A system can be defined as an interrelated components work together to achieve a common objective.
Correct, teacher.
Yeah, the definition of the system. A system is made up of input, processing, and output.
Correct, teacher.
Teacher.
Yes. A spool, a vehicle, or a bicycle can be introduced as system.
Yes, teacher.
Yes. A system not consist of interrelated components or subsystems.
False, teacher.
False. Subsystems are having specific objectives.
Correct,
Correct,
teacher.
teacher.
Yes, subsystems also having specific objectives for the those, and there is a main objective for the main system. So the subsystems are trying to achieve each of the objectives of their own, and finally by just joining, it will try to achieve the ultimate goal of the main system. What is incorrect? Barcode, MICR, OCR, OMR are direct entry input devices.
Correct, teacher.
Yes, direct entry means without interfering or just by less interfering of the people, the devices are catching the data. That means using devices without involving or less involving of people, it's input data. QR is not suitable for the data that is changing regularly like price. What about that? QR code is that suitable to the frequently changing things? That means in order to store the frequently changing information, can we use a QR code? Like price
No,
nowadays in Sri Lanka, the price are hugely changeable. In that case, in order to store data like price, we can't use QR codes. Normally, the QR codes we use in order to store the constant data, like a website, right? Hardly change whenever. It's just it's not regularly changing, right? Like then අපි අර මොකද්ද full pass එකේ QR code use කරන්නේ because the registration of the vehicle, those and the identity card number, those are hardly changeable now. When you are changing your vehicle only, it will just change. Otherwise it won't change now, right? MICR is a scanner used to read MCQ paper answers.
false, teacher.
False. What is used for MICR?
It's used to check the accuracy of bank checks.
Yeah, in order to read the bank checks, in order to read the checks. In order to read MCQ paper, What is the device we use?
OMR teacher.
OMR. OCR is used to identify written or printed characters as text format.
Correct teacher.
Yes, correct. Where we can see this facility?
Libraries, government institutions.
Yes. What is it? Can you name a device that we can see this facility? Just flatbed scanners. Normally, if a scanner is having this facility only, that scanner can scan the text as text format. Otherwise, if the OCR facility is not there with the scanner, then all the text will read as some images. Then if you read that text as images, you can't do any modifications for the text. Voice scanner, face scanner, fingerprint scanner use biometrics. Biometrics.
True teacher.
Yes, that is correct. So what is incorrect?
Third one.
Third one. What is incorrect regarding printers? A plotter is a printer that interprets commands from a computer to make line drawings.
True teacher.
True. Plotter is a kind of printer. It's a huge size of printer, and normally the printing is happening like as lines. Line drawings are there. Lines විදියට තමයි line මම පෙන්වන්නේ දෙක. line විදියට තමයි අර මේ pens draw වෙන්නේ එකේ. Thermal printers used in fax machines, receipt printing machines.
True teacher.
True. The thermal printers are used in the point of sales counters. The point of sales it uses these thermal printers in order to print the bills, and the conductors in the buses, they use that. Like I said, in the ATM machines itself, they also have thermal printers, right? Inkjet printer is a non-impact printer.
Correct teacher.
Correct. Dot matrix is an impact printer.
Correct teacher.
Correct.
Teacher.
Non-impact printers print the characters by striking them on the ribbon.
False teacher.
False. Impact printers are just striking the paper, right? Non-impact printers are just not striking the paper. So we'll just submit. Did you have this kind of thing?
Yes teacher.
Chimneys. Oh my God. Is that a chimney? $33. What are the incorrect things? Select examples for big data. Social media data, correct. Yeah, I have selected the non-select select which is not an example for big data. I have selected the answer in the opposite way. The correct answer it has given like this. So in that case, maybe yours also that is correct. I have just have a mistake there. And the other thing is that the incorrect, yeah, the services of telnet, yeah, that also the other way around it should be here. What is that is not a service of internet. Because of telnet, we can eliminate that answer. Because the telnet is not a service of internet. It's just a separate service. It's just a separate application, not related to the internet. So that two questions, because of the designing is bad. Maybe 33 are hit, yeah, maybe all of are correct. Right, sorry for that. Right, let's move on to the today's part. So I will give you another quiz from the next part, next day, right? Examples of it that we did this one. Right. Von Neumann architecture. We have to discuss from here. Right. Now the von Neumann architecture means this is also called as the stored program concept. This is the architecture that is based to the modern computers, right? The today's computers, it use this architecture, and this is invented by John von Neumann, right? John von Neumann. I just missed that part. John von Neumann was the inventor of this architecture, and this architecture is based on the stored program concept, right? So von Neumann architecture is just an architecture that is based on this concept, right? Now, what is this concept? Stored program concept means the data and instructions are stored in a memory, right? In order to process the data and instructions, those are first stored inside a memory, because in the computers that was introduced in the very earlier stages, there was not a memory. That means everything just real time, just input, process, and just output. No any memories there. But with the introducing of this stored program concept, only a kind of concept like storing, right, introduced. So under this von Neumann architecture, mainly there are 4 parts, right? A CPU is there, a memory is there, input devices are there, and the output devices are there, right? So input devices, that is to input data to the keyboard, to the computer, and the CPU is to just process those data, and the memory is to hold the data and instructions, right? And output devices are just to output the information, right? Now, CPU fetch instructions from the main memory at a time and execute it. Now, if you take this diagram, I will just explain through this diagram, right? Although I have, although the diagram has shown like input devices, it's just passing the data to this particular part, right? Normally, whatever the input that is taken through the input devices are first passed to the RAM. Okay. Here the memory unit may be the primary memory as well as the secondary memory, right? Memory unit, it's just referred to the primary memory or the RAM as well as the secondary memory or the hard disk, right? Both are representing by this memory unit. Now, say you are taking just like 2 plus 3. These are the data that you are taking through the keyboard, right? Those are some input data. And once you input those data, it will just send that to the main memory first, right? Now it's reside in the main memory. Now, in order to calculate that 2 plus 3, that is in order to do the calculation, the CPU, this part, the central processing unit is this whole part, it has to be taken that data from the RAM. Right now, it's this arrow is just for that one. It's taking this 2 plus 3 data into the CPU. Right now, if you take the CPU, there are 3 parts: control unit, the arithmetic and logic unit, and the register part. Control unit is used to send the control signals or just the clock signals to each and every part of the computer. That means it sends control signals every time to each of these parts, like say to the input devices, it just sends control signals, as well as to the arithmetic and logic unit part, it just send control signals. And if you take this registers again, it just send control signals. And from here, it sends control signals to the output devices as well. And also the control signals are sent into the memory units. To each and every part of the computer, the control unit will send the control signals, right? Okay, now what is the arithmetic and logic unit? What is the purpose of that one? It's doing the calculations or just the logical arrangements like AND gate, OR gate, XOR gate. That logical operations are done by this arithmetic logic, and calculations like addition, subtraction, multiplication, all are done by this ALU part, right? And what are the registers? Those are the parts that used to hold the data and instructions temporarily within the CPU. Now say, after taking this 2 plus 3 data to the CPU, until it's calculating by the arithmetic and logic unit, there should be a place in order to hold this data inside the CPU. Now, by after just taking this 2 plus 3, where it should store until it's just calculating as 5. The arithmetic and logic part, just do the calculation. 2 plus 3 as equal to 5. It will done by this one, right? But until it's doing this calculation, the data should be placed in somewhere. No? So that is the registers are there, right? So there are several registers available. The PC, CIR, NTR, NAR, AC. These are the most regularly used registers by the CPU, but there are thousands of registers available. Right now, we will in the future slide, we will see what are the duties of each of the registers. That slide I have missed to put in the presentation. That is why I just put it into the WhatsApp. Right? Just in your tute, write down the purposes of each of these 5 registers. Right? That is very important. What is done by the PC, CIR, right? Each of these purposes you need to know. So I have missed that one in my presentation. So I just send it today to your WhatsApp, right? Just keep that note even into your tutor, maybe to the presentation. Okay. Right. Now the registers are, what is the purpose of registers here? It just temporarily hold the data and instructions that is needed by the CPU. Right? Okay. Now say the arithmetic part, it will done by this ALU, right? Now the answer is 5 now, right? So in order to hold that 5 answer temporarily, again the registers are used, right? Once this calculation is done, where until it is sent to the RAM, until the 5 is sent to the RAM, it should hold by some register. Right, that part also done by the register. Then may input data අරගත්තට පස්සේ ඒව තියාගන්නෙත් registers වල. After done the calculation, the answers also again stored in the registers, right? Until it is sent to the memory unit. Okay, now say the registers are storing that part 5 here, not in the accumulator. Maybe inside a data register it will store, right? Now from the CPU, it will send that output again to the RAM, right? Again to the RAM, it will send that output. It will not keep the output by itself, just it send the output to the RAM again. Then if the output devices are needed to see that output only, the output devices has to be taken that particular output from the RAM. Right? Output devices also, they cannot directly access to the CPU. They have to take the data, whatever the data that is needed to display to the output devices, they have to take from the RAM. Right? Input devices also put the data into the RAM. And also in order to take the data by the output devices, that data should be there in the RAM. And also the data that is needed by the CPU, that also needed to be stored in RAM. right? Now from one at a time, the CPU will fetch data from the RAM. The RAM will hold the input data and instructions. The CPU will one by one, it will fetch the data from the RAM and it will do the calculation. And again, after doing the calculation, it will just send the output to the memory unit and it will take another data. It will fetch another data from the RAM. So it will just do as a cycle. That means it will fetch a data from where? From RAM, right? CPU fetch a data from RAM and CPU execute that data. Execute means it's just do the calculation and then again it will take another data and again execute, right? These two steps happening forever as long as the RAM is available data to process, right? As long as the RAM is available data and instructions to be processed, this cycle is going on, right? It will fetch some data from the RAM and just execute. Okay, so this is called as the von Neumann architecture. There are 4 parts. You have to know what are the 4 parts and what are the purposes of each of these parts, right? That means what is the purpose of input device? You know that one. What is the purpose of input device? It will take the data inside to the computer. Right? Output devices, it will gives back the information to the outside. Then memory unit, it hold data and instructions. CPU, it process data. Right? Simply gatot ehemaine. Right. So in this slide, it has stated the purposes of each of this part, right? If you take the central processing unit, again, what is the purpose of ALU? It allows to do the arithmetic and logical operations. Arithmetic operations means addition, subtraction, multiplication, and division. Logical operations means the AND gate, OR gate, and NOT gate. So the people who have done all levels, they know this thing, but others don't worry, right? We will discuss that in next topic, right? That is ALU, and registers are there to store inside the CPU. That means the data must be stored in a register before it can be processed. That means until it is processing the data, the CPU is holding the data inside these registers, right? Until it is processing by the ALU, the CPU will keep on these keep the data on these registers. Then controlling it, it controls the operations of computers, ALU, memory, and input-output devices, and telling them how to respond to the program instructions. It has just read and interpret from the main memory unit. No need to have this kind of lengthy explanation. Just what is the purpose of controlling it? It just controls all the devices of the computer. That means input devices, output devices, the memory devices, CPU, everything it's controlling by just sending some control signals, right? So that is the purpose of CPU. Then I will move on to this slide later. And what is the purpose of memory unit? Memory unit consists of RAM here, right? Or secondary memory, right? So the memory unit consists of RAM, sometimes referred to as primary memory or main memory, right? We call primary memory, main memory, or RAM. Unlike a hard drive, this memory is fast and also directly accessible by the CPU. So what is the memory that is directly accessible by the CPU? That is RAM, right? Normally, මෙතන memory unit කියලා කිව්වම RAM and ROM, RAM and secondary storage both are differing, but in some cases only it's referring the RAM, right? Because if it is the secondary memory is there, then හිතමු මෙතන secondary memory එකක් තිබ්බ කියලා. Secondary memory එකක් තිබ්බොතින් say this is RAM. This is the hard disk for the secondary memory. Right? Now say some data is there stored in the hard disk. Right? And it's needed to process that data by the CPU. In that case, the hard disk should first hand over that data to the RAM. Then from RAM only, it will take to the CPU. So all of these memories we can refer as the memory unit. Both are there inside the main memory. But if there is something inside the hard disk, in order to process that thing, first it should bring to the RAM. Then from RAM only, the CPU can directly take that one. Because only the CPU can directly access is the RAM. It cannot directly access the hard disk. Right? And again, the reverse that also same. The CPU first send the data to the RAM. Then if we just save the data only, it will send that RAM data into the hard disk. Once we save the data, the RAM will send that data to the hard disk permanently. Then input devices and output devices I didn't mention here because you know that thing. The purpose is very clear for you. Right? And we'll move on to the purposes of each of these registers. Right? Now I'll tell you inside the CPU there are several registers. Right? So these 5 registers are very important because it's regularly used. Right? What is this accumulator? AC here this is the accumulator register. Right? Accumulator is the register that is holding the answers for the calculation. That means after it's doing some calculation, the result will be stored inside the accumulator, right? It stores the results of calculations made by ALU. Now, in the previous case, the 2 plus 3, the answer was 5. That 5 is stored inside the accumulator first. Then it will send to the RAM, right? First, it will store in the accumulator. Then program counter, the PC, that is, it will show the next instruction to be executed by the CPU. That means in order to process the data by the CPU, one by one instruction it is needed to take by the CPU. Now how the CPU is deciding which instruction or data I have to take in which time. මොන වෙලාවට මොන ඉන්ස්ට්‍රක්ෂන් එකද මම අරගෙන ප්‍රොසෙස් කරන්න ඕනේ කියලා යා තීරණය කරන්නේ මොකක් දිහා බලලද? By just looking at the program counter value, the CPU will decide this is the next instruction that I have to execute. That means this is the next calculation that I have to do. That the next instruction the CPU should do, it's mentioning in the program counter register, right? And so normally the program counter is keeping the memory address of that instruction. Okay, the memory, again, now say this is the RAM, right? It's just having some cells here. Say 2 plus 3, there are 3 cells storing this particular data. The 2 is there in one cell, plus is in the second cell, the third is in the third cell of the RAM, right? Now, in order to do this calculation, that data should be sent to the CPU one at a time. Now, the program counter, the PC, right? It's mentioning what is the memory address that the CPU should take next time. That means what is the memory address of the data that is needed to execute next time by the CPU. Then first the PC will include the memory address of the 2. Say the memory address is AAA, this is BBB, this is CCC, These are the memory addresses of these cells, right? Now, at the very first, the PC will show AAA, right? It will just showing AAA inside the PC counter. That means the CPU now know, next instruction that I have to take is reside in that particular AAA cell. So it will just go to that AAA cell of the RAM and it will just take the data. Next, next time, after taking that 2, next time the PC will showing BBB. That means it's tell the CPU to take the next data that is available in the BBB address. It's just show the memory address of the relevant data. It's just not show the data, but the address of the data. Now, after fetching that data, then the CPU, the PC will show, you have to take the next instruction from the CCC cell. Likewise, it one by one, it will instruct the CPU to take the instructions from those, just take the instructions from those cells, right? That is program counter. Then memory address register is what? It stores the memory location or the memory address that need to be fetched from memory or stored into memory. That means currently executing address එක. දැන් හිතමු දැන් MAR එකේ තියෙන්නේ MAR is it's just holding the currently executing data's memory address. Right now, say the CCC is just the instruction that is taken to the next time now. Now, what is the memory address it is currently processing? That is BBB. Right? The currently executing thing is the BBB one. The next instruction to be executed is CCC. What is the difference in between these two? The next instruction it shows here, and the currently executing instruction it shows here. Not the instruction, just the memory location. So memory addresses it shows here, right? And what is the MDR? MDR is just the register that is holding the currently executing data. That means now the currently executing instruction is reside in BBB. Now, what is that relevant data? That is plus. That plus data is stored inside this MDR register. Right? So PC and MAR just holding some memory addresses. And MDR is just holding some data. Just the direct data. Right? And what is CIR? Current instruction register. That means it stores the most recently fetched instruction by the CPU. Right? It just shows what is the most recently by the CPU. Just the CIR. Right? What is the latest instruction that is done by the CPU? It shows here. So just this 5 is enough. You have to study what are the purposes of each of these registers, 5 registers. Okay? Because this knowledge you need into the operating system lesson as well. Then buses, right? Now buses means in order to navigate through the motherboard, right? Say the CPU is there, and the input devices are there, the output device is there, and the memories are there. Now, in order to go here and there through these components, there should be some paths or roads available. Just in the motherboard itself, there are some paths available, right? Those paths or some just routes, right? We call as buses. Now, there are 3 kinds of buses available. Data bus, right? Control bus and address bus. Now, from the name itself, you can just identify the data bus are just carrying out some data only. Okay, now in the previous case, like 2 plus 3, right? Those parts or those buses are just carrying the data only. Now, what are the control buses? The control buses carry the control signals. Now, you know the control unit is sending control signals to each and every part of the computer. Now, in that case, that control signals are traveling through these control buses. It's just only send the control signals to the components, right? And address buses are just carrying the addresses. Now, in the previous case, I told you this the program counter register and the MAR register, those are just stating some memory addresses now. So in order to store that memory addresses inside that registers, the memory addresses should travel through these address buses. The addresses are traveling through the address buses, right? Just those buses are totally designed to carry the addresses only. They are not carrying any data or any control signal. Now, if you take the data bus, those are bidirectional. That means, say, from a data bus, it can be go here as well as there, right? Both directions through a data bus, you can travel data. But if you take a control bus, maybe some data buses are there that is omnidirection. That means unidirection. Some control buses are there. It sends some control signals only for the one direction only. But there are some other control buses that's working on two bidirections, right? And address buses always just one direction. Address buses are unidirection or one direction, right? So you have to know the purpose of each of these register and what is the direction. Is that unidirection or bidirection, right? Then just we'll move on to the tutorial now. Von Neumann architecture, page number 6. Von Neumann architecture. Von Neumann architecture consists of memory and input output devices. What is the missing part here? 4 parts should be here now. Memory is there, input is there, output is there. What is the missing part? Yes. What are the 4 parts of von Neumann architecture? Yes.
CPU.
Yes. CPU. CPU. The data and instructions are stored in where?
Main memory.
Main memory or RAM. Main memory and RAM. The fetches an instruction from the memory at a time and execute it. Who fetch the instruction from RAM? Yes. What is the part that fetches data from the RAM? CPU. Right? CPU tama fetch karane RAM එකෙන් data. Right? CPU fetches the data from the RAM. And now the participants here is 4 has missed. I have to note down who are those. Right. Then just you have to fill this diagram. You have to start from input devices. Yes. Here, the last one. Make a
Output devices.
output devices. Right. Inside the CPU, only 2 parts has mentioned there. The 2 main parts you have to put here. What is the first part? control unit. Next one,
Arithmetic and logical
and
unit.
yes, arithmetic and logic unit, or the ALU. Make it a CU. This is ALU, and this is what is this part?
Registers.
Memory unit. The registers had not put there because the main two parts of the central processing unit is these two only. That is why it has given here. Some diagrams it's showing three, but most of the diagrams it just showing these two parts only. Right? This part is the memory unit. Right? This is the central processing unit. That box, this box is the CPU, whole thing, and this is the memory unit. Right, memory buses. Buses. What is it carrying? Data bus carries data. Control bus, what are it's carrying? Control bus is carrying control signals. Address buses are carrying addresses. Addresses of memory locations. Right? Addresses of memory locations. Then direction of data. It should be off. Data buses, is that unidirection or bidirection? Data bidirection, right? That means it's going data here and there. That means if you take a bus like this, if it is the route, then the data can go through this path into this direction as well as into here. Right? Both directions it's possible. Control signals, uni or bi. That means some control signals, some control buses, it's carrying data into one direction only. But some control buses, it's carries control signals to both of the directions. Then address buses,
Unidirection.
yeah, it's only to one direction, unidirection only. Right? Just this summary is enough regarding buses and the definition of bus. What is mean by a bus, right? So, what is the definition? Buses. Buses are the means by which data is transmitted from one part of a computer to another, connecting all major internal components to the CPU and memory. So, just take the idea. That means buses are the routes or parts that is connecting the components inside the motherboard. That definition is enough, right? It's just connecting the components. Right, then the fetch execute cycle. That part also we can cover up today. Right. Now, fetch execute cycle is nothing, just describe that one Neumann architecture. Right now, normally what's happening, the data and instructions is stored in where? It's stored in RAM or primary memory, right? And CPU will fetch those data and instruction one by one. It will fetch one data at a one time. Then it will just decode that instruction. Paste instruction or data. Then CPU will decode the instruction. Decode means it will just analyze what is needed to be done by this instruction, right? Because it just needed to convert into the machine language and just realize from this particular instruction what is the actual thing I have to perform. That means, say, Is that an addition I have to do here? Or is that a subtraction I have to do here? What is the thing that I have to perform? That is mean by just the decoding. Decoding means just this analyzing what is the real thing that I have to do. That is done by again CPU. And then it's executing. Execute means what? That also done by the CPU. Executing means it just doing that calculation, right? Doing that calculation. Once it identify or analyze what should do, then it will do that thing. So these are the parts of the von Neumann architecture. And fetch execute cycle is there inside this architecture. Right? Now, what are the steps of this fetch executing cycle? First, fetch an instruction from ROM. This is the first step. Right? Just include the numbers, right? Then it's for you. This is the first step. It will fetch an instruction from RAM. Now, this is happening in the RAM. That means the CPU will fetch an instruction. It will just catch or take an instruction from RAM. Because the RAM is containing all the data and instructions now. Whatever the data and instruction that is inputting through the input devices just stored in the RAM. Out of that set of instructions, the CPU will fetch one at a time. Then it will decode that instruction. That is done by the CPU's control unit part. Make karane CPU එක තමයි, but from which part? Control unit part is done by the decoding. I told you what is mean by the decoding. Decoding is what? It just analyze what is the actual calculation. What is the actual process that I have to do? Is that an addition? Is that a subtraction? Or is that a logical operation? It will just analyze or just understanding what to do with this instruction. That part is done by the control unit. Then after decoding or just analyzing, just realizing what to do, then the ALU part of the CPU, that is again in CPU now, the ALU part will execute that instruction. What is mean by executing? It's just running or it's just doing the calculation, calculating or processing. Everything is same. Executing means maybe it's doing the calculation or maybe it's just sorting something, or it's maybe it's doing some process. Whatever the calculation part, the processing part, the actual processing will happen there. That is by the ALU. Okay. Again, what will happen? After executing that one, again the CPU will take another instruction from the RAM and again will decode that one by the control unit of the CPU. Again, it will execute by the ALU and it will go on like a cycle. Right? Now, this is one diagram, you can show that one. And this is another way. This way also there are in some cases, in some papers, right? So what is the starting point here? Fetching is the starting point. Here, number one is fetch. Right? Where the fetching is happening? From the RAM. It's just fetching instruction from the RAM because the RAM is storing data and instructions. Right? So it will fetch the data from RAM. Then the control unit of the CPU. This part is there inside the CPU control unit. It will decode that data. Then same place in the CPU, but from the arithmetic and logic part, it will execute that the instruction. That is the third step. And it will store again in RAM. That means the answer I told you, once the answer is calculated, it will first store in the accumulator register and then it will soon pass into the RAM. It will not hold any output by the CPU because it's having some limited capacity only with the register memory. So no any space there to hold everything. So just by doing the calculation, the output again sent to the RAM. So the RAM will store that temporary But if you save that one, the store will temporarily make a it will temporarily hold that data. But if you save that one, it will go to the secondary memory of the machine. That means the hard disk. Right? Once it's saving the data, it will store permanently in the hard disk. Right? Now, this is depicted in 3 steps, but some cases it's showing as 4 steps. So you have to know both. Right? Don't confuse if it's showing 4 parts. Just the last part is for store the result. Then, then again this diagram. Step 1, it's here. What is the step 1? Step 1 means fetching instruction from main memory. Now here the main memory, right? From main memory, it just fetch data. After fetching data, where it will go? It will go to the control unit, because the step 2 is there happening. That means the decoding. The decoding is happening inside the control unit. That is why from main memory, the data will go to the control unit. Then from the control unit, it will send that data to the ALU, right? Because its execution or the processing is happening inside the ALU. And from the ALU again, after done this final calculation, it will send that result again to the main memory. That is step 4, right? So normally this is called as fetch execute cycle, or in some books it's referring fetch decode execute cycle. When you are receiving the questions as well, maybe both you have to familiar, fetch decode execute or fetch execute, right? Is that clear? Fetch decode execution. Right now, this is don't by heart this the table things, right? Just what is happening actually in deeply I have mentioned here, but no need to by heart this one. Just take an idea by reading the scenario. No need to by heart, right? Because it's just showing what are the purposes of each of these registers. PC, then that means one by one functions. It's PC containing the next instruction to be executed. Then what will happen? Then it will pass to the MAR, from there to MDR, then to CIR, and so on. No need to by heart this, just read and understand, right? So what are the stages of fetch, decode, execute cycle? Now I explain things. Data and instructions are both stored in binary digits and stored in primary storage, right? That means data and instructions where it's stored in primary storage, right? Normally, you know, it's storing as binary digits, right? Because if it is a digital device, the computer is a digital device, it hold all these data and instructions in binary memory. Then the instructions are fetched by CPU from memory one at a time and in order, serially by the CPU. That means those data and instructions, right? Among those data and instructions, the CPU will fetch one by one data and instruction in an order. That means first it will do the first thing, then the next. There's an order in order to fetch that. That means it will not happen randomly. Just there's an order, because in order to do a calculation, there's a particular order. No? In order first, in order to do this calculation, what are the data that it should fetch first? It has to take this 2 first. Then it has to take the plus operator. Then the last time it has to take this 3. Likewise, there's an order, right? So the fetches data from RAM one after the another according to an order. Then after fetching the data, CPU will decode data and also it will execute the data. The decoding part will happen inside the control unit of the CPU and the execution part will happen inside the ALU of the CPU. And it will cycle, it will continue this cycle until no more instructions are available in RAM. As long as the RAM is available, data and instructions to be executed by the CPU, this cycle will go on, right? Once the RAM doesn't have any data and instruction, then this cycle will be stopped, right? Again, I have this registers I have put here now. Yeah. So again, no need to have this note because I thought it has missed by me, but it's there inside this slide. Yeah. Regarding the registers, it's here inside this slide. No need to take down the notes again. Right. Then only one slide in order to end up this session. And we can move to the past paper questions next time. And hope to give you the second quiz as well. Now, in order to practice the things, I have to give the second quiz like today, as well as we will discuss some past paper questions regarding these two topics. And I hope to start the third lesson. That means the number system lesson next, right? After end of that part, we will move on to the third lesson. That is a calculation based one. Everything there is calculation, no any theory parts. Yes. Okay. Multi-core processors. Multi-core processors means I explained you regarding this course in the first unit, right? I told you there are some names of the processors, that is dual core. Then core to do, right? Likewise, there are some cores. That means cores means if you take a CPU, it's having some chambers or just some parts are there inside the CPU in order to process. That means say there's a huge calculation to be done. Say this is a calculation to be done, right? Now the CPU is having several cores, core 1, core 2, core 3, likewise, right? When the number of cores are increasing in the CPU, then the efficiency of the CPU will be increased, because now normally if the CPU is having only one core, in order to process, first it will take this 2 plus 3 part into its core. Say the CPU is having only one core or one room here, right? So it will do this calculation first. 2 plus 3, that is 5, right? Then it will take the division. The next one, division 4. Then it will take 5 divided by 4 at the second time. And then maybe the answer is say 1.8, right? Again, the third part, 1.8 into 5, right? So this whole calculation, it will do in 3 steps. The addition part first, then the division part, then the multiplication part. If the CPU is having only one core, it has to be done in 3 steps. But say the CPU is having 3 cores at the same time, the CPU can hand over this calculation into the first core, right? Then the division by 4, that is to the second core, and multiplication by 5, that was part to this third core. So at the same time, simultaneously, parallelly, all these 3 calculations are running. So I took here an example, right? So because of that parallel processing or simultaneous processing here, it will speed up the calculations, right? So when the number of cores are increasing inside the CPU, that means you can do multiple tasks at the same time, right? Now I took here only one calculation. Now say likewise, there are several jobs that you have to do. Say you have to type a Word document. Then you have to do some Excel calculations, and also you have to do some PowerPoint presentation. Now there are 3 jobs. Now if you have a multi-core one, you can hand over Word job to one core. Then at the same time, you can hand over Excel to second core, PowerPoint to third core. Likewise, you can divide the processes that you have to be processed into this cores, right? So anyhow, it will enable the parallel programming or parallel processing, and it will increase the performance of a single machine by having this multi-core processors. Normally, nowadays we are having what? i3, i5, i-family, right? i7, i9. That means the number of cores are just increasing. Here it's having 3 cores, 5 cores, 7 cores, 9 cores. Right now you can feel that when the number of cores are increasing, that means the efficiency or the speed of the machine is also just getting increased, right? So that is the end of this lesson. So we can continue the tutorial next time, and also please study the first unit, the rest of the unit, the first rest of the first unit. I will design a quiz for you all next time, right? Okay, then you can leave.
Teacher.
Thank you, teacher.
Thank you, teacher.
Teacher, is the next lesson the one with all the calculations?
Next lesson, no. Maybe at the end of the next lesson, we can start the new lesson. That means the third one. Hopefully, we can start it on next time. Not sure, because we have to cover up the past paper questions from these first 2 units now. After doing that one, we can just move on to the third one, right?
Okay, teacher. So the third lesson is the one with all the calculations?
Yes, yes. The number system one is fully calculations.
Okay, teacher.
Just the number conversions. Have you done all-level ICT?
No, teacher.
Then you have to study from beginning, right? No, don't worry, just easy. Right.
Okay. Thank you, teacher.
Welcome.